Hi there, welcome back to video F29.5 compound interest mixed practice. So this is just a continuation of the previous page with a lot more room for me to write. Okay, so these are mixed up questions. Let's see what's going to happen. But, there's really one formula. So let's start here. Oh, I guess this connects to the question on the previous page. Oopsie. Okay. How much would I need to invest if I had thought of this 30 years ago? Okay, so now it's talking about 55 years. And from the previous page, it was, hold on, semi-annually and 7.5%. Times 2, 110, 7.5 divided by 100, divided by 2. Still 0.0375. But now, I guess it is the same question. Still a million here. Okay, so if when I was little, or maybe some rich family member left me a bunch of money when I was little, how much would I have had to invest in total 55 years ago? I would have been, never mind. They just don't tell that information. Don't guess. Actually, guess, send me an email. I'm very curious if anybody watches this. All right, so you know what? I'm using that same formula I did a while ago. So P is equal to A over 1 plus I to the n. And because I don't want to screw this up, I have my nice formula chart there. Yep, that's the right one. So it's still a million on the top. 1 plus 0.0375. So my interest hasn't changed either, but now instead of 50, it's 110 for my exponent. Okay, 1 million. 1, 2, 3. There we go. Divide by bracket 1 plus 0.375. Oopsie, 75. There we go. And now we need an exponent and 110. I suspect it's, I want to say a lot less, but I don't know. Oh, only 17,000 when I was little. E is equal to $17,430.44. That's a huge amount. But I guess the long and the short of it is, if you can save even slowly when you're younger, please do, because it does add up if you can just get it into an, just put it away, no touchy, no touchy. Okay, I laugh because this is my favorite story. When my dad was like 12, my grandparents in the 1940s bought life insurance on him, which makes me think my dad was a bit of a hooligan. And it was, I think, a $600 policy, which probably was an insane amount back then. That policy just collected interest. Nothing happened. I was gonna say, I think a couple of times my dad wanted to cash it in when we were farming, and Mom said, "I don't know where it is," and she was lying. She knew exactly where it was. And that $600 was worth almost $20,000 when my dad passed away, when he was 80-ish. So put some money away, forget about it, no touchy, and there'll be something there when you're older. Anyway, that's my financial advice for you today. Back to work. I have $25,000 and I would like it to grow to that amount, $12,000 in 5 years. Before I go any further, that makes me think I'm going to need a pretty high interest rate because it seems kind of crazy. And clearly, I didn't leave myself much room. Okay, so this is part A. What interest rate will make this happen? So A, P, I, N. And again, if you're stressed out over what to do first, just start with that. Oops, made it worse. There. I have 2,500 now, and I want to grow it to 12,000. And it said what interest rate? Okay, so I don't know that. And my N is 5 years. Oh, 12 is 60. So this is going to be divided by 100, divided by 12. Okay, so we are looking for interest. And now I'm going to look at there, and I'm going to recopy my formula. So there. And now I'm going to write it down here where we're working. Because to get full marks on these, and honestly, just to get good at them, rewrite the formula every single time. Especially on a mixed question like this. I is equal to A over P, and 1 over N minus 1. So my interest rate is equal to 12,000, which is the amount at the end, divided by 2,500, which is my principal, the amount at the start, 1 over 60, because that's my N minus 1. Thousand, and move so you can see. Divide by 2,500, close my brackets, exponent, open a bracket, 1 divided by 60. And you're going, is it always 1? Yes, it's always 1. Minus 1, bloop. So interest is equal to 0.2648. I'm not going to worry about my rounding right now. And I need to multiply by 10, 100, and times 12. Remember, the answer we just got is the one that's sitting here. So we need to, there you go, make your row better. Multiply by 100 times 12. So interest rate is equal to 31.79%. I just rounded. I didn't write out being lazy. It's the end of the day. Cool. All right. Suppose I left the money in the account as described in part A. How long would it take the money to go to 15,000? Okay, good question. B. So A, P, I, N. No, I started with 2,500. Now this time I want it to grow to 15,000. Okay. How long is described? So I guess just hold on while I consult my answer key. I'm just going to pause because this isn't making sense. One sec. I'm back. Sorry about that. I just wanted to make sure that I was using this interest rate here that we've just figured out. divide by 100, divide by 12, because we're still looking at compounded monthly. Now, I think I already know what that answer should be. 0.79 divided by 100. Oops. So you can see divided by 12. Yeah. Okay. Probably yelled at me. I lost a 0 from right there. Okay. So there we go. And that's going to be 0.02649. That's probably enough. And that's why I don't teach finance. They'll tell you how to round. All right, so n is going to be, oh, we get to use a logarithm one. Log a over p divided by log 1 plus I. So n is equal to 15,000 over 2,500 over log of 1 plus 0.2649. All right, 15,000 divided by 2,500. Oh, good at 6. Don't need that. Okay, so I need to go logarithm 6 divided by logarithm 1.02649. And n is equal to 68.53. What the heck? Ah, my friends, but wait. Remember, this means monthly, which means this is in months. So if we divide that by 12, 5.7 years. Let's go check my answer. All right, 69 months. Yep. All right. Now, remember that crazy rule of 72? I'm just going to take a moment here and play around and show you guys. Okay, so which means to take 72. And this is always, this marginless, this moves too, for estimates. What was my percentage? 31.79. Okay. 31.79. 72 divided by 31.79. Okay, so 2.26 years to double. Okay, what? Seriously, how does this fit with that? Well, that's to go from 2,500, and if we double that, that's 5,000. Okay, so that's, let's just go 2.26 years. And then if we double that, we get 10,000, which is another 2.26 years. And if we double that, we're at 20,000. See, I can do my multiply by 2. That's going to take 2.26. So if I go 2.26 plus 2.26, okay, so up to here is like 4.5 years, And then it says it's going to take me 5 years, 5.7 years to get to 15,000, which is before what that total would be. And if that last little part about Rule 72 confuse you, we can just pretend it never happened. I won't tell anybody. Have a lovely day.